right, we were talking yesterday about hybridization, okay? Yes. We talked about how we can take an s orbital and 3p orbitals, and we can combine them together to make 4 sp orbitals, okay? And I showed you how we would do that, like with carbon and hydrogen. Okay, you could have a carbon in the middle, and then you would have, so here's your carbon, one of your sp orbitals, another sp orbital, another sp orbital, and another sp orbital, and then your hydrogens would be attached off to here, but they only have an s orbital. Okay, so I think that's about where I left off yesterday. When I did that, we were talking about these bonds between the carbon and the hydrogen. Now, when these orbitals attach one another end to end, and there's not really an end in a sphere, but if there were, when we attach those, this type of bond here is called a sigma bond. All single bonds are sigma bonds. All single bonds are sigma bonds. Sigma bonds, which are sometimes abbreviated like this. Okay, it's like an O with a little curly Q thing coming out of it. That is, what was I going to say? That is end-to-end orbitals. Okay. Now, we can have situations where we have double bonding going on. For example, when we talk about, let me find one here. Oh, carbon dioxide is a good one. Okay. CO2. Okay. For CO2, if we look at just the carbon, okay, if we draw this out, we've got our carbon, we've got it double bonded to an oxygen and double bonded to another oxygen here. Okay, so this is what that Lewis dot structure would look like. Now, we have a single bond here. This top one right here, we call that a single bond. Okay, so the first bond of our double bond is going to be a sigma bond. So that's a sigma bond. And then the second bond of that is called a pi bond. So that's the second bond in a double bond. If we had a triple bond, it would be the second and the third. Okay? Yep. Yep. So a pi bond is side to side. Okay? A sigma bond is stronger than a pi bond. I'm going to show you in a minute. Okay, so if we're just comparing a sigma and a pi, the sigma is going to be stronger. But if I have a sigma versus a sigma and a pi, so a single bond versus a double bond, the double bond is going to be stronger. Does that make sense? Okay. All right, so let's talk about this. When I have a pi bond, pi bonds cannot occur in hybrid orbitals. Got it? So you can't have one of these for a pi bond. Okay? Pi bonds cannot occur in hybrid orbitals. Okay? So that means that when I'm dealing with this, and if I am looking at my carbon, that carbon is going to have 2 pi bonds on it. Yes? So I have to have 2 p orbitals that are not hybridized. So these are going to be the orbitals that I am going to use to build my CO2 for my carbon. Good? Huh? Okay, what don't you know? So this carbon has 2 pi bonds, right here and right here, yes? Okay. Pi bonds can't occur in hybrid orbitals.
So the top 2 are the yellow bonds.
Yep, and that's going to be these 2. Matthew?
Okay, yeah.
The top 2 are always sigma, the bottom 2 are always pi. Okay, what if there's third? Or like
it's going to be a pi.
Okay.
So if you had a triple bond, like if you had 2 carbons here, like this guy, you would have these 2 would be pi down here, and this guy up top would be a sigma.
So there's always a sigma.
Always a sigma.
And then the H's are
Yep, these would be sigma bonds as well. Hydrogens can only single bond because they only have 1 orbital.
And then sigma bonds always look like that shape over there. And pi bonds.
Not always. Let me draw them out, okay? Let me draw this structure together, okay? Let me draw this CO2 and maybe that'll make a little more sense. I just wanted to establish some ground rules first before I really got into this.
What's the C underneath it then?
Okay.
Or is that just
This is, I'm talking about the carbon here, okay?
So they can't be hybrid because the ones have to be the B shape.
Okay. Now my oxygen, how many pi bonds does the oxygen, we're just looking at oxygen. How many pi bonds does this oxygen have? 1. How many does this? These structures for the oxygens are going to be identical. Yes, everybody can see that. So if I'm, if I'm looking at the oxygen now, I'm going to have 1 p orbital reserved for this. And then the rest of these are going to be hybrid orbitals. Okay? Everybody cool with that? Because we have 4 things going in, we got to have 4 things coming out. Okay? So if I have for the oxygen and for the carbon, okay, with the carbon, I started with an S and 3 P's. That's 4 things. I'm going to come out with 4 things. For the carbon, that's going to be 2 that are hybrid, that are look like this, and 2 P's. For the oxygen, then I'm going to go in with this. I'm going to come out with 4. 3 of those are going to be hybridized and 1 isn't. Correct. All right. Now let me start drawing this for you. I'm going to start here, and then I'm going to go over to this side. So for my carbon, I'm going to start with my carbon, which is black. I'm going to have my center here with my 2 hybrid orbitals. I'm going to have 1 coming off one side and 1 coming off the other side. Okay. I have now drawn this orbital and this orbital. These 2 orbitals are drawn in my drawing right here. Looks like an airplane propeller. Okay. Now I'm going to go and I'm going to draw in the oxygen that is going to connect with the sigma bond right here. Okay. So that means that's going to be a hybrid orbital. That's my oxygen on the one side. This right here is a sigma bond. They are side to side. I'm sorry, end to end. Just like I said, sigma bonds have to be end to end. Okay? One end to the other end. Okay?
Okay.
So now, and maybe I should just be erasing these as I'm going through because that'll clear this up a little bit. So I'm going to get rid of this guy because I've got him drawn in. I've got him and him drawn in. Okay? Now I'm going to go to the other side and I'm going to draw the sigma bond end for this oxygen. Oh, shoot. Hey, sorry.
I'll step back maybe during your prep.
Yeah, my prep is, dadgummit.
0. You don't have a prep.
My prep is first and third. So, sorry. Thank you.
Send your email.
Thanks. All right, I got that reestablished. My apologies. Okay, now I'm going to go and I'm going to draw in the sigma bond. That's this bond right here. Okay, so that's this sigma bond. These should be the same size. I just have trouble drawing. Okay. Now, that takes care of those. We also have, for the oxygen, these guys right here. Okay, these lone pairs of electrons. So I'm going to go and draw those in now. Oh, shoot. Okay, here. So there's an sp orbital, and I've got a lone pair of electrons, lone pair of electrons. Here's an sp orbital. I have a lone pair of electrons, lone pair of electrons. Now I'm going to go over here and do the same thing. I'm going to move this up just to get it out of the way. Okay. Now I'm going to draw this one in and this guy, and I'm going to put those lone pairs of electrons in. And that gets rid of these two there. So I've got all of those drawn in now. I've got these lone pairs of electrons drawn in. I've got my sigma bonds drawn in where they're end to end. And now I need to go back and I need to draw in my pi bonds. Okay, so pi bonds have to have p orbitals. Pi, p. Use your alliteration. So I'm going to draw in my p orbital here. I'm going to draw in a p orbital here.
Oh, yeah.
Okay. That is the p orbital for this sigma bond here. And the p orbital for this sigma bond here. Now that needs to bond with something. So I'm going to draw in. So I've got these two drawn in now. They're there. Now I just got to go and draw this guy in. Okay. I'm going to get him drawn in. He's going to be my oxygen. So I'm going to draw my oxygen one in. And then I'm going to draw this one's in. And remember, pi bonds are side to side. So that's what we mean by side to side. And when we're talking about pi bonds, this is my pi bond. Is that making a little more sense now? Sigma versus pi. Okay, so that's what we're talking about. Now, for AP Chem, you will never have to draw anything this complex in. Okay, it's never going to be this hard. But to understand what's going on, I like to take you through this. Okay, so what do you need for AP Chem? You need 3 fingers. Okay, like seriously. Okay, that's all you need to be able to figure this out. Okay.
Do you have balloons for a nice representation?
Not right now. Okay, So I've essentially gone through these slides. This is what we're going through next. Okay. When we draw these out, bonds, let's say that we had CH4 here. Okay. I draw this out as my Lewis structure. I hold up 3 fingers. I take one down for each double or triple bond around the central atom.
I remember this.
I didn't take any down. This hybridization is sp3 because you would have 3 pi orbitals that would all hybridize. Okay? Single bond lone pair. That would look something like this. Hold up 3 fingers.
You're good.
Take one down for each double triple bond around the central atom. Hybridization is sp3. Okay. Single and one double. So I gotta think of something that has a single and one double. Yeah, here we go. Oh, that's really grating. That whoever's humming, whistling. All right.
It was.
Okay. So we're looking at the central atom. We're trying to figure out its hybridization. Okay. I'm going to take one finger down for each double or triple bond around that central atom.
sp2.
So I take one finger down. That means it is sp2. That's it. That's as hard as it is. If we're talking about this guy here, okay, they might ask you to identify the hybridization of every element in that compound. So we're going to start with our oxygens. We're going to hold up 3 fingers. We're going to take one down for this. So it's going to be sp2. This one will be sp2. The carbon, I'm going to take one finger down here, one finger down here. So it's going to be sp.
So we won't have to draw the thing we just drew. We just need to know
The complex thing with all the bubbles and everything going on. No, you will never, ever, 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 ever have to do that. No. Yeah. You just need to know this. But the thing is that if I tried to explain this to you and didn't go through that, you would have no idea what I was talking about.
I have a question. Can an expanded octet ever have 3 double bonds? Or does that have to be 6
I don't know for sure.
But that one.
But you also will never have to bond, or I'm sorry, you will never have to hybridize expanded octets. Okay? So you will never have to do SPD hybridization. It exists. Okay? So you may have to do it in college, but for the AP exam, no. Okay? Yeah. This gets ugly. Okay? So you don't have to worry about that right now. Like I said, once you get all these foundational courses down and you go on to take chemistry way above where I'm at, you may have to do that. But you'll be ready for it by then because you'll have all this other stuff licked. Okay?
Licked?
Metaphorically.
I would hope so.
All right.
Like my little
So do you see how to do this? All you have to do is use your fingers. Hold up 3 fingers. Take one down for each thing. Does that work? Okay. That's as hard as hybridization is going to be on the AP exam.
So it's basically easy.
What's on the
3
AP?
points.
Okay. So let's determine hybridization. We just did these 2. Okay. Now, hydrogen does not hybridize.
We know
It doesn't have a p orbital, so it cannot hybridize. So
SP,
they're asking you for the carbons here. So this is carbon 1, carbon 2, carbon 3, and carbon 4. So here, carbon, I'm going to take one down for this, one down for this. So my carbon, my first carbon is going to be
SP1.
sp. We don't do the 1, just like, math. All right, carbon 2. What is it going to be? Same. It's going to be sp.
So a triple bond takes off 2 fingers.
Yep. Carbon 3. sp3, and carbon 4 is sp3 as well. All right, let's go over here. We've got 1, 2, 3, 4, 5, 6. 6. 1, 2, 3, 4, 5. Yeah, we got 6 here. So take a second, see if you can figure out carbons 1 through 6.
SP2, SP2, SP1, SP1, SP3, SP3. No, SP3, SP3, SP1. No. Okay.
Okay, so my first carbon, what is it going to be?
SP2.
sp2, because we would have taken 1 down here. This carbon's going to be the same thing because we take 1 finger down for this.
What's the name of that? Oh.
This thing, I don't know.
C6H8.
All right. This guy here, what is he going to be?
SP3.
sp3.
So is 4.
sp3.
Then SP.
This one's going to be
SP because of the
And so
triple
is the
one.
last one.
okay.
Okay.
Easy enough? Easy enough?
Is that what
Okay. So this is where I was talking about the sigma and pi. I've got it in the notes where you can kind of look through it, but it's the same stuff that I just went through. It's just easier if I kind of go through all of that at one time instead of going through the notes. Okay, now keep this in mind. This is a common question on there. Okay, so a pi bond, this side to side bond here, that's not a good drawing. The side to side bond here is your pi bond. That bond is weaker than an end to end bond would be for the sigma. Okay. But if you combine these two together, they're stronger than just the single bond. Okay. So this is a typical kind of question that comes up. So be careful with that. Now, sigma bonds can rotate freely. So you have a rotation where this could rotate around and spin so that CH3 could be at the top and this could be at the bottom. When you have pi bonds, though, because of that side-to-side action, you can't get that rotation anymore. And so this is locked into place. And that'll become important as you guys move up into organic chemistry and stuff like that, which will be in college. It will not be here. All right, we talked about bond order, I believe.
Yes.
Okay, yep, number of bonds divided by bond sites. So we've covered that. We've talked about resonance. So we've talked about how when this is actually happening, we've got that. And our bond length, when we look at this, if we have resonance going on here, that means that the bond length for both of these yep. I don't know why this isn't letting me write.
Do the rainbow sparkle one. Do the sparkly rainbow one. The sparkly rainbow one will work.
It just hates me.
Maybe
Do sparkly rainbow.
You wear your Apple Watch like that?
I have been, it's been like, no, it's causing a sore there from where the electrical thing comes through. And so, I just have it flipped around right now because
Have you ever used the markers
it's burning
yet?
me. Okay. So when we have a situation here where we have resonance, then we look at the bond length. The bond length for both of these would be 1.5. This question comes up every year, something like this. It may not be this molecule, but something like this will, and they will fool you, a good portion of you every time. When you have resonance here, so for example, this, they will ask you the bond length for this, and you'll see this and you'll go, well, this one's going to be 2, and this one's going to be 1. And since this has resonance, that's not the case. This is 1.33, 1.33, 1.33.
But if it doesn't have
Right. Then that's
resonance, it would
different.
be-
Yeah. So if this was like two different elements here, then it wouldn't be resonance anymore.
So if there's like a double bond,
Mhm.
it's not the same element you would multiply.
Well, no, it can be the same bond. It can be the same element though. If yeah, so it could be. If resonance can exist, then that bond length is going to get. You have to factor that into the bond length.
Is this table movable?
No,
So you've never
Why is
multiplied
it
a
at
double
an
bond
angle?
by 2.
you might.
Is it at an angle?
Yes.
I don't know why I can't write on this anymore.
Look at the tape doesn't.
But you could just like
Yeah, like that.
you could just measure the length of the thing too. But you can see that that side's supposed to that line. This one is supposed
I don't know what I was even talking about anymore.
to. I was wondering like when it was
Oh,
like
yeah.
1.5
So-
with the double bond, it wouldn't be 3 since you're 3.
No, it wouldn't be 3.
Because you wouldn't double it since it's a double bond.
Like here.
Yeah, like if the other ones are 1, that wouldn't be 2 since it's a double bond.
Yeah, this one would be because we don't have resonance here.
So you would double that.
Ben, stop. Sit. I can't concentrate right now. Go sit down.
Can you mark? Does your marker work yet?
No.
So this bond length here would be a 2,
If
Okay.
the other ones are 1.
and these would be 1s. Yes. And while there would be resonance here
But
because
it
you
doesn't
could
change
shut,
where the
shut,
bond is.
yeah, because you could draw this where these two are flipped around. Okay. So there would be resonance here, but you can't move that double bond to any other location.
So
Okay.
you would
Right.
double it.
So that's why, yeah. Okay. Does that make sense?
Yeah.
So this bond length is going to be 2,
But like then
or bond order. I mean, bond order.
then that one, the double bond would still be 1.5 instead of 3 because it
Yeah.
would go on the other side.
Mm-hmm. All right. So see if you can determine the molecular geometry, predict the bond angles of these guys. Have we done this already?
No, this is like
Okay. Oh, this is the I do. Okay. I'm going to try closing this program down and reopening it and seeing if that will allow me to draw on this thing again.
regular tabs already in unit 3. Or is that R?
It's just chapter 3. Okay, here we go. Let's see if this will work now.
Use the rainbow one.
Please.
I'm telling you, the rainbow one will work. The rainbow one. Do you have to be in the full screen thing?
Ah, there we go. Okay.
Use the rainbow.
All right.
Can you try the rainbow pen?
Yes. Use the
Yay!
rainbow one.
This one?
No, there was a rainbow color.
There it is.
Yes.
I like the second one more.
Okay, Ben wants the second one. You gotta increase the thickness.
Yeah, why is it so
The
So-
second. Yeah.
Oh, ooh.
All right.
Yay.
So I have my iodine here. It's going to be my central atom. It's going to connect to a chlorine and a chlorine. I need to figure out my number of electrons. This is going to be 7 times 3, which is 21, plus another electron because of this. So it's going to be 22 electrons that I need to place.
this one could have it extended.
Mm-hmm.
I don't want to do this. Not that.
All right.
Whoa. Oh,
16 here.
don't you need the 1, 2's in the middle?
And then 18, 20, 22.
Wow.
Google.
That's a fancy iPhone. Ice cream is fun.
We need to go back to our chart from yesterday and figure out what this geometry is.
2, 3.
T-shape.
It's linear.
Isn't it linear?
It's
No, wait.
linear.
There's 3 sets of water.
No, it's linear. I mixed them up.
It's linear.
I meant 3.
Trigonal bipyramid linear.
Okay, so I have 2 atoms around and 3 lone pairs of electrons. So this is where I'm at.
Z.
So that means it's linear.
So that's the molecular.
That is the molecular geometry.
Whoa.
Bond angle then is what?
180.
180.
I really like this pen.
What's going to have to happen to this sulfur?
Extended out.
Expanded octet. Yep. So we're going to have 5 things coming off of this guy.
Excuse you.
That's not creepy at all.
Oh no, not this lady.
Okay. I'm going to figure out how many electrons I've got. I've got 7 times 4 is 28 plus 6 is
34.
34 plus 6
40.
is
40.
40 electrons. Okay. So go and fill up my fluorines. And then go and take care of my oxygens and make sure I haven't gone through too many electrons in the process.
No, we're good.
Okay.
5 times 8 is, yeah, is 40. So we're good.
Isn't this oxygen?
All right, now we need to go and we need to figure out our geometry. So I have 5 and 0. So 5 and 0 is trigonal bipyramidal. It's 120 in the plane and 90 perpendicular to the plane. Okay. So yeah, I understand that now. Okay. So what's happening with this is we've got a sulfur here. We have a fluorine, and a fluorine coming off. Okay. And that's all in the same plane. Okay. So you got 3 things coming off of that same plane. And then you've got coming up out of that, you've got an oxygen and another fluorine.
Whoa.
Okay. So you've got your central atom, which is sulfur. You've got an oxygen and a fluorine, and then coming out of here, you've got 3 things coming out of this. Does that make sense?
No, yes.
So which one do you put?
It's resonance, so you could redraw it if you wanted.
No,
Which
the bond
angle do you put?
Oh, the bond, you would put both of them down.
You
Yeah.
have to say which one's in the plane.
Mm-hmm. Because you've got 3 things coming off of the center, and then these are going to be at 180 coming this direction. So you've got three things. 1, 2, 3. Just pick 3. And then these two are coming up and down. Do you understand how this is working? Like what's going on with this? Here, let me. I can't use that. Oh, here. This is good. Okay. It looks like this. Okay. Sulfur is in the middle. Okay. You've got an oxygen here and a fluorine here. And then you got a fluorine, fluorine, fluorine coming off. Okay. Does that make sense? So that's what we're talking about. So these would be going around, and then you've got them coming up and down.
That's animal.
Oh. That's it.
What did you just do?
All right, draw the Lewis structure for this guy. Include the hybridization on the central atom and the total number of sigma and pi bonds in the molecule. So when we draw this, four,
10.
yep, 10. Okay.
And don't forget.
All right, hybridization for both of these is the same. What is it?
Do we have to put the brackets and the minus too?
Yep.
Oh yeah.
Hybridization on both of these is the same. What is it?
SP.
SP. So we've got that answered. Okay. Indicate the hybridization. Indicate the total number of sigma and pi bonds. So how many sigma bonds do I have and how many pi?
2.
1 sigma, 2 pi.
Cool. Next one.
How do you draw the sigma sign? It's like a O with the line on the top. Okay.
All right. We want to know the hybridization of the central atom. Hybridization of this guy is sp2. They want to know the total number of sigma and pi bonds in the molecule. So how many sigma bonds do I have in the molecule?
3.
3. 1, 2, 3.
Okay.
And then that's a pi bond. So I've got one of those. All right. Ammonia is ammonia, polar or non-polar. It should take you that long to figure it out.
Polar because it has dots.
Right. It has a lone pair on the central atom here. Okay. We are going to talk about molecular shape here. The molecular shape for this is
I haven't even looked at it. Trigonopyramidal.
pyramidal, right?
Trig pyramid.
Mid.
Dot. It's PY.
Okay, there we go. It's not. Lippy can't spell.
Rough.
Are we gonna go back over like the hybridons and stuff at all?
Dipole moments.
IMFs?
Yeah.
Yeah, we get to those
That's
X
in
unit.
unit 3.
Yeah.
See? It goes IMIMS.
All right.
Ideal gases.
So molecular shape, polar bonds. Polar bonds. This is nitrogen is 3 and hydrogen is 2,1. So 3.0 minus 2.1. The bonds are 0.9. So they are polar bonds. Dipoles cancel using arrows. They are not going to cancel. You are going to have
Positive on bottom.
the positive down here, and you're going to have the negative on the top where the lone pairs are.
So
Yes,
pairs are
sir.
normally where the negative.
Yep. All right. Consider these structures. The carbon-carbon bond has the highest bond order. Which one of these has the highest bond order? Ethene. Yep. And then they wanted to know which one has the lowest bond order. The other one. All right. So Monday and Tuesday are work days for your entire packet. Okay. I would not wait until Monday and Tuesday to do it. Okay. You have a weekend. I would take advantage of that.
We have a beer.
You do whatever y'all need.
For 3 days.
How many packets?
3 days.
Hold on.